Have you ever stopped to think about how some of the biggest revolutions in history actually started with the smallest things? Well, today, we're diving into a piece of tech that's so tiny and so cheap you could easily just miss it. But believe me, it is quietly powering a massive shift in how our entire world works. So, let's get into it.
All right, take a look at this. I know, it might just seem like another circuit board, right? A complex little maze of components, but hidden right there at its heart is a tiny computer that is punching way above its weight. And the secret it's holding? Well, that's the key to connecting our physical world to the digital one. So, what in the world is it?
Okay, the star of our show, the brain of the whole operation on that board we just saw, is something called the ESP32. It's a tiny little chip with an impact that is anything but small.
So what is an ESP32? Well, the easiest way to think about it is like a miniature, totally self-contained computer all on a single chip. It's designed to be super efficient, so it sips power. But the real magic, the secret sauce, is that it has Wi-Fi and Bluetooth baked right in. And it's all run by a surprisingly zippy dual-core processor. It's the whole shebang for connectivity in one tiny package.
Look, it's not just that the ESP32 is powerful or that it's connected. It's the fact that it combines all of these features while being unbelievably cheap. We're talking just a few dollars. And that makes it the perfect tool for pretty much everyone, from a student building a robot in their bedroom to a massive factory automating its entire production line. This little guy is the engine of the Internet of Things.
Okay, so that all sounds great in theory, but how does this little computer actually work in the real world? How do you go from a chip on a board to something that's actually useful? Well, let's look at a fantastic case study, making a regular old coffee machine smart. So here's the puzzle. We've got a standard coffee machine, and we want to know what it's doing. Is it heating up, brewing, or just sitting there? Now, we could try to crack it open and mess with its internal electronics, but that's invasive and super complicated. There's a much smarter way. Let's just watch how much electricity it's using.
So we hook our ESP32 up to a sensor, and we start collecting that power data. But we hit a snag. As you can see from this chart, real-world data is messy. It's noisy. See all those little dots way off to the side? Those are called outliers. They're just random spikes and errors that are hiding the real pattern. Trying to find a clear signal in all this mess is tough.
And this is where the smart part really kicks in. We can apply a machine learning algorithm that basically teaches the system to just ignore all that noise. And suddenly, poof, the chaotic data from the last slide becomes this: a clean, beautiful, understandable picture of the machine's actual power usage. All those pesky outliers are gone.
And this right here, this is the aha moment. The graph on the left shows that clean power data over time. The one on the right, that's tracking when someone physically presses a button on the machine. And would you look at that? The exact moment the button is pressed, bam, a huge corresponding spike in power. Our ESP32 can now perfectly link a physical action to a digital event. That's the game changer.
Okay, so we've made a smart coffee machine. Pretty cool project, right? But why does this one little example matter on a global scale? It's time to zoom out and see how this one idea builds into something much, much bigger.
This brings us to a huge concept people call Industry 4.0. You might have heard it called the Fourth Industrial Revolution. The core idea, as this quote puts it, is all about creating smart factories where every single machine, every process, and all the data are woven together through the internet.
And it all works in this really simple but powerful loop. Step 1, you use cheap, connected sensors powered by chips just like the ESP32 to gather data from everything. Step 2, you use machine learning to analyze all that data in real time, just like we did with our coffee machine. And step 3, you act on those insights to make the whole system smarter, maybe predicting when a machine will break down or finding new ways to save energy.
Now, this whole revolution really has two main goals. On one side, you have process optimization. That's all about using data to make the factories and supply chains we already have way more efficient. And on the other side, you have product innovation, creating totally new kinds of smart, connected products that were just never possible before. You even start to see a shift from just selling products to selling ongoing services.
So a powerful chip lets us build smart factories, which then changes the whole economy. Okay, but that leaves one giant question. How did this incredibly advanced technology get so cheap and so accessible in the first place? Well, the answer lies in a revolutionary idea that's changing the very way we invent things. The answer is open source, and it's a simple but really profound idea. Instead of keeping your designs and your code a secret, you make them public. You just put them out there for anyone to see, to learn from, to improve, and then to share their changes back with the whole world. It's basically global, collaborative teamwork for innovation.
So why are so many companies and developers jumping on this bandwagon? Well, a major study in the EU found 3 key reasons. First, to avoid what's called vendor lock-in. That's where you become totally dependent on one single company's secret tech. Second, and this is a big one, is to slash costs. And third, people are realizing it's just a better, faster way to advance technology by pooling everyone's brainpower.
And I mean, just look at the result. This graph shows the number of code contributions being made to artificial intelligence projects on open-source platforms. It's not a gentle slope upwards, is it? It is an absolute explosion of collaborative development. This is what happens when you tear down the walls and let people build on each other's work. It's incredible.
So wow, we started with a single chip, we zoomed out to see an entire industrial revolution, and we landed on a global movement of collaboration. Now let's bring it all home and see what this really means for our future and for you.
You see, this isn't just for hobbyists anymore. The open source movement has become so powerful that it's now a core part of economic and even geopolitical strategy. The European Union, for example, sees it as absolutely essential for making sure it has its own technological independence and for driving innovation across its entire economy. It's a big deal.
And here's the crucial part. This stuff affects you directly. It's the foundation of the whole right-to-repair movement, because when hardware and software are open, you can actually fix your own stuff. It makes it way cheaper for new startups to get off the ground, it helps people build critical tech skills, and it creates a much more sustainable system where we can actually extend the life of our electronics instead of just throwing them away.
So when you connect all these dots, from a cheap little chip to smart machines, all the way to a global collaborative movement, you really have to step back and ask yourself, what kind of future is this actually building?
And maybe this is the answer. We always think of progress as some lone genius having a eureka moment in a lab. But maybe the next great leap forward won't look like that at all. Maybe it'll be millions of small contributions, a million tiny collaborations, all made possible by open, accessible technology. That all started with a simple little chip that cost less than your morning coffee.